Welcome to the Explainer. Today, we're taking a virtual lab tour to decode the Ingress Protection rating system, officially defined by the international standard IEC 6D529. You've seen these ratings on everything from your smartphone to heavy industrial sensors, but what do they actually mean? Well, today, we're going to see exactly what physical torture tests these devices have to survive in the laboratory to earn those rugged marketing claims.
Here's our roadmap for this explainer. First, the anatomy of the IP code. Then we'll hit the dry lab for solid ingress, the wet lab for liquids, a deep dive into IP67 versus IP68, and finally, the extreme IP69K rating.
Section 1, Anatomy of the IP code. Let's get our decoder rings ready. So the whole foundation of our tour is IEC 6005029. This is the international standard that actually replaces all those vague consumer marketing terms, things like waterproof or dustproof, with precise, scientifically verified classifications. It gives engineers and consumers a standardized framework we can actually trust. It details the exact degrees of protection an electrical enclosure provides against solid objects getting in, including human body parts, and of course, liquids.
And what's kind of cool is how simple the code anatomy is once you break it down. It literally always starts with IP, Ingress Protection. That's followed by a first digit rating solids and a second digit rating liquids. Now, if a device wasn't tested for one of those, you're just going to see an X instead of a number. You might also spot some optional letters tagged on the end, like an M if it was tested for water while its moving parts were in motion, or an S for stationary.
Moving right along, Section 2, first digit solid ingress. Let's hit into the dry lab.
So that first digit scales from 0 to 6. And hey, this isn't just about dust, it's really about mechanical safety. Level 1 kicks off with a 50mm sphere, basically checking if the back of a hand could accidentally bump a dangerous electrical part. Level 2 gets way more specific using a 12.5mm jointed test finger. It literally probes the enclosure to make sure human fingers can't touch anything live. Moving up to levels 3 and 4, the lab brings out 2.5mm and 1mm steel rods to simulate tools and thin wires. Then, levels 5 and 6 tackle fine particulates, which requires a totally different setup.
To score that ultimate level 6 dust-tight rating, devices don't just sit in a dusty room. Oh no, the procedure is brutal. The enclosure is locked inside a specialized dust chamber, continuously circulating fine talcum powder. But here is the kicker. They attach a low-pressure vacuum pump right to the device. This creates a pressure differential that actively forces those fine particulates toward every single seam, gasket, and gap for up to 8 hours. To pass level 6, absolutely zero dust can get inside. None.
All right, Section 3, second digit, liquid ingress. Time to step into the wet lab.
These liquid tests escalate kind of like video game boss battles. Levels 1 and 2 start out super gentle with vertically dripping water, testing devices that might just face some light condensation. But by levels 3 and 4, things ramp up. The device gets hit by oscillating spray tubes blasting water from 60 degrees to all directions. By levels 5 and 6, the lab brings out the heavy artillery, high-pressure water jets. And for the final bosses, levels 7 and 8, the equipment is dropped straight into immersion tanks.
To really grasp the violence of these tests, let's look at a level 6 liquid rating. The enclosure has to survive a punishing blast from a 12.5mm hose nozzle, firing 100 liters of water per minute. That is a massive amount of water. We're talking 100 kilopascals of pressure blasted from just 3 meters away for at least 3 minutes. Basically, they're proving your device can take a direct hit from a powerful industrial pressure washer without any harmful water getting in.
Next up, Section 4, IP67 versus IP68 submersion. Let's talk about those immersion tanks. So you see IP68 heavily marketed on everything these days, from rugged smartphones to high-end dive gear and marine sensors. But seeing that exact same rating on wildly different products really begs the question, right? Is every single IP68 rated device equally waterproof? Well, the short answer is absolutely not. And the long answer? It's critical if you're buying or designing equipment.
Here's a major plot twist in the IEC standard. IP67 is universally standardized. If something is IP67, you know for a fact it's sat in an immersion tank with its lowest point exactly 1 meter deep for exactly 30 minutes. IP68, on the other hand, stands for continuous immersion. But, and this is a big one, the exact depth and duration are completely variable. They're entirely defined by an agreement between the manufacturer and the user.
The literal only rule is that the test has to be more severe than IP67.
So the absolutely crucial takeaway here is that IP68 does not equal one fixed test. One IP68 smartphone might only be tested at 1.5 meters for 30 minutes, while an IP68 marine sensor could be built to survive 10 meters of depth for days. Because there's no universal depth or time limit tied to that number 8, you literally always have to read the fine print on the manufacturer's datasheet. Never just assume an IP68 rating means you can take the device deep-sea diving, unless the specs actually back it up.
All right, final stop. Section 5, Extreme Testing, the IP69K rating. Step in to the steam room.
Now, IP69K wasn't even in the original base IEC standard. It actually comes from a German standard, DIN 4050-9. It was custom-built for heavy industrial sectors. We're talking engine bay components in the auto industry and the food and beverage processing industry. In food processing, for example, facilities do these rigorous, completely sanitary daily washdowns to maintain hygiene, and all their digital displays, sensors, and machines, they have to survive that daily assault.
To earn this elite rating, they put the equipment on a turntable, rotating 5 times a minute. Then they blast it with close-range water jets heated to a blistering 80 degrees Celsius. That's 176 degrees Fahrenheit. And that water is rocketing out at 100 bar, which is roughly 1,450 psi of pressure. It's aggressively directed from 4 different angles at just 4 to 6 inches away. It is literally the ultimate, mind-blowing test of seal integrity and thermal shock resistance.
And that brings us to our conclusion, navigating the ratings. Let's wrap up this tour. So, let's recap what we've learned. The IEC 6059 standard totally eliminates the guesswork. The first digit protects against physical solids, scaling from 50mm lab probes all the way to vacuum-sealed dust chambers. The second digit tests water intrusion from gentle drips up to 100 liter per minute jets. Always remember the IP68 trap. You have to verify the specific manufacturer depth and duration. And IP69K, that's your go-to for ultimate high-pressure, high-temperature steam cleaning.
Now that you know the exact physical torture tests behind those abstract numbers, I want to leave you with something to ponder. Look closely at the equipment you buy, use, or design. Does your device's IP rating actually match the real-world environment it will be forced to survive? Knowing these lab tests is the absolute key to ensuring your gear doesn't fail when you need it most. Thanks for joining me on this explainer, and keep questioning the specs.
Like and subscribe.